Hi and welcome to ExHAC. In this example, we will perform a classification design of a fuel gas manifold in an outdoor location. The manifold handles natural gas, which is comprised mostly of methane and trace amounts of other compounds. The manifold incorporates on-off control valves that control the flow of natural gas. In this scenario, the most likely source of release will be a leak from a valve component. To begin our analysis, we first need to define the project. Let's create a new project and define it as example 1 and name it Fuel Gas Manifold Application. The altitude is 1000 meters. The minimum ambient temp is -20 degrees Celsius, and max ambient temperature is +40 degrees. The location of the manifold is in a refinery. If we want, we can add additional information in the project description. In this example, we will indicate the project is a refinery area classification update. Click Submit once you are done and the project should appear in the project list. Next, let's define the flammable compounds involved in the release. Since this is a natural gas manifold, the major compounds are methane and ethane, with trace amounts of other gases. In the FMA tab, Flammable Mixtures section, we see that a generic natural gas compound mixture is pre-configured. To view the mixture composition, click on the View tab. We do not need to create a new flammable mixture if this composition is acceptable. Keep in mind that if your natural gas composition differs from our generic compound mixture, you will need to configure your natural gas mixture as a new custom flammable mixture. For now, let's use the generic natural gas composition in our analysis. If you go under the FMA tab, FM Analysis module, and click on Natural Gas, you will also be able to access the properties of natural gas. Keep in mind that you cannot edit a pre-configured generic flammable mixture. We will cover how to define a custom flammable mixture in a later example. Now, we will create the source of release. Before we can proceed, we need to determine the most probable source of release. In this example, a valve release would be more likely than a flange release source, because a valve is a moving part in service. Let's name this SOR, Natural Gas Manifold. This is a gas release, so we select gas or vapor release. Next, we define the stream temperature at 50 degrees Celsius. Our stream pressure is 8000 kPa. The grade of release is secondary, as we do not expect a release to occur in normal operation and, if it does, it will last for a short period of time. The ambient temperature is 20 degrees. Click Submit. And we see that the SOR appears in the SOR list. If we need to adjust the parameters of our SOR, we can do this by clicking on the Edit button to review and change the SOR parameters if necessary. The next step is to define an enclosure. Since our manifold is located outdoors in a freely ventilated area, we can skip this step and go directly to configuring our hack analysis. Now we start the hack analysis. Click Create Hack. Add a new hack. Select the Project Fuel Gas Manifold application. Next, select FMA number and the FM name natural gas. Next, select SR number and select natural gas manifold from the list. Given that this is a non-enclosed application, there is no need to select an enclosure. Press the Configure Analysis push button, and the configuration parameters we need to review will appear on the right side of the screen. Let's go through each of the default parameters provided by ExHAC and override any parameters if needed. ExHAC defaults the type of release to diffusive for gas and vapor releases. For a jet release, we can click on the Override tab to configure our release as a jet release for our example. The default wind speed is set at 0.3 meters per second. If we click on the wind speed, Table C.1 from the IEC standard is displayed. For unobstructed areas less than 2 meters, 0.5 meters per second is recommended. Click OK and enter 0.5 in the override cell. Since this is a gas release, the pool surface area and wind speed at pool surface are not applicable to our analysis and are indicated as NA. To select the appropriate coefficient of discharge as per IEC standard, click on the parameter. Let's assume a rounded hole release in our assessment because a valve involves moving parts that will wear over time. A coefficient discharge value of 0.99 would be appropriate. To select the appropriate hole size, click on the clip art to access Table B.1. Our example incorporates a valve stem packing subject to wear. Table B.1 recommends a hole size of 2.5 mm squared for the analysis. Let's use this value, and enter the recommended value in the override cell. For the saturated vapor field, a natural gas release will be in a vapor state, so the ExHAC default parameter false is valid. We will go with ExHAC calculated parameters for stream compressibility and the stream polytropic factor. We will also assume that the availability of ventilation is good as the manifold is in freely ventilated outdoor location. The remaining parameters are all defined as NA, as they are not needed for our analysis. If we are satisfied with parameters we have configured, we can press Start Analysis. To view the results of our analysis, we click on the HAC Output tab. The analysis indicates a Zone 2 classification is appropriate for the application, with a 2.65 meter horizontal and vertical extent. The charts allow us to visually review our analysis. If we want to further refine the analysis, we can go back to the HAC Input tab, and revise our input parameters, and rerun the simulation. If we are satisfied with the results, we can add a comment to the Notes section on the screen, and then press Save Analysis to store our analysis in our HAC database. To create a report from our analysis, go to the HAC tab, and select the HAC Analysis list, and look for the analysis we just completed. Click on Create Report, and the report will be displayed. You can save the report for archiving purposes, or export the report as an Excel file. The ExHAC in an IEC format table can then be used as a basis for documenting your design. Once our analysis is complete, we need to apply our results to our natural gas manifold. For a jet release, the IEC standard suggests two possible shapes for determining a release extent. Figure A.3 is applications where we know the release direction. Figure A.2 may be used for applications where the release direction is not known. In most cases, Figure A.2 will apply. If we apply shape A.2 to our manifold example, the classification degree and extent will look like this. A 2.65 meter Zone 2 classification extent surrounds all release sources on the manifold. The group classification is defined as 2A, and the auto-ignition temperature for the application is 515 degrees Celsius, corresponding to AT1 temperature code. Our hazardous area classification design, for this natural gas manifold, is now complete.